Hi all, now let's see the code implementation for OR gate using this neural network. Now we know that for the perceptron with two inputs, so here I am saying two input perceptron, my output equation is something like output, which is nothing but 1 when my equation x1 w1 plus x2 w2 plus my bias becomes greater than equal to 0, or else we get output as 0. Okay. So now here we saw in the lecture video of OR gate, we came to the conclusion that let me set my W1 as 1, let me set my W2 as 1, and let me set my bias as minus zero point 0.5. Now when I do this, I get output 1. If I substitute this value, this will be x1 plus x2 minus zero point 0.5. When this value will be greater than equal to 0, we will get the output as 1, otherwise 0. So this equation which we have defined here, this is nothing but acting as one kind of activation function. Activation functions are nothing but the functions which trigger your neurons to do some certain task, to activate those. So now there are many activation functions like sigmoid, tanh, relu. This particular function is called a step activation function. So how it is defined as, let me show you on a graph. Say this is 0. Whenever the value which we have is less than 0, whenever we get the value of this equation, whatever we have, if this is less than 0, then my output will be 0. As soon as we get that equation value as 1, my output becomes 1. So this is how a step activation function looks like. So as we are defining same conditions here, we are calling it as a activation function, which is nothing but a step activation function. Okay, so this we will be using in our code. Now let's jump to the code. So now let's see the OR gate neural network code line by line with a detailed explanation of what each part is exactly doing. So first thing first, let's import the library. That is nothing but we'll need NumPy as a library. So this line imports the NumPy library, which is widely used for this numerical operations in Python. Next step, let's define our activation function here. So this defines the activation function for our neuron. The step function is used if the weighted sum, that is nothing but z, is greater than or equal to 0, then we get output as 1, or else we'll get output as 0. The step function is used to simulate the firing of a neuron. Okay, if the weighted sum z is greater than, means my neuron is fired and we get output as 1. But if it is less than 0, we get output as 0. That means the neuron is not fired yet. So this models the behavior of a simple binary neuron used in a logic gate simulation. Now next, let's design our neural network for OR gate. So here I am defining one function with the two inputs, that is nothing but x1, x2 here. So this is a function definition for neural network that simulates the OR logic gate. It takes two inputs x1 and x2, which can be 0 or 1. Then this line where we are giving this equation calculates the weighted sum z. This is nothing but a weighted sum, that is 0 of a input plus biases. So here we are considering W1 as 1, W2 as 1 and bias as minus 0.5. So we have just put the values in it so that we get the output Z for each and every input. This equation mimics how the biological or artificial neuron combines inputs before deciding to activate or fire the neuron. And then this line, which is nothing but implies that the step activation function to z, it will return for this particular weighted sum. It returns 1 if my z is greater than equal to 0, or else we get 0 as the output from this function. Now let's do the testing part. Here I am just writing all the inputs and then calling the function or neural network for each of the input, and let's see what output we get from the model which we have developed here by writing a manual equations. So now let's run the code in our Google Colab notebook and see the output. Here again I am using the shortcut, that is Shift Enter, to run a particular cell, And now here we can see that for 0 and 0 only we get output as 0, and rest of the combinations we get output as 1, which is exactly the behavior of a OR logical gate. Now what we saw was a traditional way of designing OR gate using neural network. Now let's see how we design a neural network using some libraries like NumPy, TensorFlows and Keras. Let's start with it. First thing first, let's import the libraries. So here NumPy is for creating the arrays of inputs and outputs. Then I am taking sequential, which will let you stack the layers in a straight line. Then we have this dense, which is nothing but a fully connected layer where each neuron is connected to all the inputs. Then we have this input that is nothing but explicitly define the shape of the input which we will be taking. And then we have this SGD, which is nothing but stochastic gradient descent optimizer to train the model. Now next, let's define our inputs and outputs. So here my X is a 2D array where each inner list is a pair of inputs for OR. And here Y is the expected output for each input pair based on the OR logic. Now next step, let's build the model. Here I am taking model as sequential, which means layers are added one after another. Here input shape I am taking 2, which tells us that the model will have 2 inputs. And here I am dense 1. This 1 is nothing but telling us one neuron in the layer output layer, and the activation function which we are using here is sigmoid. We saw one more activation function which was step activation function, which we took for our manual or a traditional way of coding. There we took a step activation function. Now this sigmoid is more advanced. So here we are using this activation function now. So this sigmoid activation function will squash the output between 0 and 1. So if you get some value, say 0.2, then we set some threshold by where we say that if the value of this output is lying between 0 to zero point 0.5, my output will be treated as 0, and if it's between 0.5 to 1, it will be treated as 1. So this is how the neuron will try to learn the OR logic by adjusting the weights and biases. Now let's compile the model. For that, we are taking optimizer as SGD, that is stochastic gradient descent, and learning rate here, how big each update step is when adjusting some weights. That is what learning rate is. Okay, and then here I am saying compile, which will prepare the model for training. So this compile will prepare the model for training. Here I am taking optimizer, that is nothing but SGD, which we defined here. So this optimizer will adjust the weights to minimize the error. The loss we are considering here is binary entropy, which compares the predicted versus actual for the binary outputs, that is 0 or 1. And then the metrics we are taking accuracy, which tracks how many outputs are correct during the training. Now next step, let's train the model here. Here I am for training using fit function, that is nothing but trains the model on the data. Epochs I am taking here as 1000, that is nothing but repeating the training 1000 times over the whole data set. And here I am saying verbose equals to 0. So this is an optional parameter. So this will hide the detailed training logs. Then after training, the model has now learned weights and biases that approximate the OR logic. Now let's predict our results. How we'll do that? So here I am telling that predictions say that return the sigmoid outputs. So this predict function will return the sigmoid outputs, which can be like 0.1, 0.01, something, anything it can be, like ranging from any values between 0 to 1. Now this is happening when the model goes through the sigmoid activation function. So these are the outputs which we'll get. So now what we do is sigmoid doesn't return exact 0 or 1. So we threshold it. That means we say if my output is greater than zero point 0.5. Okay, here we'll write a condition for that. So if my output, that is predictions, is greater than zero point 0.5, tell me that it is output 1, else it will be 0. So this is how I am writing my code, where I am designing this neural network using TensorFlows and Keras libraries for writing my OR logic gate using neural network. Now let's run this code in our Google Colab notebook to see the output. So here I have taken the same code for which we saw the explanation. Now in this cell, I'll run this by using a shortcut, say Shift Enter. Now the code has started running. So we can see this triangle, this green arrow is here. That means the training of a model is going on right now. Let's wait and see what we get output. So now we have got our output. Here you can see that for only 0, 0 we are getting output as 0, and for rest of them it is 1, which is exactly mimicking the behavior of a logical OR gate. So this is how you can code for a logical OR gate using neural networks. I hope this topic was quite interesting for you guys. The links to the videos for the explanation of logical OR gate theory part is given in the description. Please go through it once to understand what is perceptron, how it is taking, and how we are setting the values for weights and biases. So if you like this video, please subscribe and keep sharing. Thank you.